Section 6.7 is the quadratic formula, along with analyzing the discriminant of the quadratic formula to determine how many x-intercepts of a quadratic function exist. So here is your quadratic formula. It is written in your notes so that you don't have to worry about copying it down. What I want you to notice is there is an opposite of b sign in front of that very first part of the formula. A lot of students tend to miss that, so just make sure that you are aware of the opposite of b. So the first equation we have is w squared equals 5w plus 3. Before we can start using the quadratic formula, it must be in standard form and set equal to 0. So I subtracted the 5w and the 3, so it was in standard form. I then labeled my a, b, and c value, where a is the value of 1, b is a -5, and c is a -3. So when I plug that into my quadratic formula, it would look like this. The opposite of b then, of -5 is +5, plus or minus, and then I just went straight to 25. So b squared is 25. If you try and write -5 squared, you might wind up getting a negative value if you forget the parentheses. So I just like to go straight to 25. Minus 4 times 1, the value of a, times the value of c, -3, all over 2 times -1. Your next step would be to find the value underneath the square root. So when you calculate that, you should get 37. The 37 is called your discriminant, so that is the value underneath your square root, and we will talk about what that means in a few moments. Next, you should take the square root of 37, round it to the nearest hundredths, and that would get you 6.08. Now I'm going to get two answers, 5 plus 6.08 over 2, and then 5 minus 6.08 over 2. So the plus or minus gives you two answers, which should turn out to be 5.54 and -0.54. Question number 2 is not set up in standard form, so the first thing I'm going to need to do is subtract the 6x and also subtract the 8. So my new equation would say -3w squared minus 4w minus 3 equals 0, where my a is -3, my b is -14, and my c is -3. So when I plug that into the quadratic formula, it will look like this. 14 plus or minus the square root of the quantity b squared. So I took -14 and squared it to get a positive 196, minus 4 times -3 times a -3 over 2 times -3. Again, the next thing I'm going to do is find the discriminant value. That's the value underneath the square root, and that should get 160 when I calculate that out. I will then find the square root of 160, which would be 12.65. And then I will do 14 plus 12.65 over -6 to get a value of -4.44. And then I will do 14 minus 12.65 over -6 to get a value of -0.225. If I just look at the value of the discriminant, so far we've gotten a discriminant to be two real numbers because the discriminant was positive. We had 37 and 160. Again, the discriminant is just the b squared minus 4ac portion of the quadratic formula. If it was negative, however, we cannot take the negative of a square root, so we would say we have 0 solutions and 2 of them are complex. If it turned out to be 0 exactly, we will have 1 solution, and that would be a real solution. So these first 3 categories talk about the number of solutions that a quadratic function will have. These second 2 then classify the types of solutions we will have. So if the discriminant is a perfect square, our solutions will be rational. If the discriminant is not a perfect square, your solutions will be irrational. So if we ask you to describe the number and type, you would give me 1 from the first 3 and then 1 answer from the second 2 columns. So how many solutions and then rational or irrational. So we can try an example that looks like this. So this table is looking for the discriminant and the number of solutions in the first column, the type of solutions, and then to find the solutions. Again, the discriminant is just the b squared minus 4ac portion. So my first formula, if I just found the discriminant, would be 49 minus 4 times 2 times 15, which would be a value of -71. So a negative discriminant means I'm going to have 0 real, but 2 complex solutions. If I then plug that into the quadratic formula to find the solutions, that would give me 7 plus or minus the square root of -71 all over 4. Because we do not know how to take the square root of a -71 at this point, I'm going to leave it in that format. The second example I would plug in would give me 256 minus 4 times 1 times 64 for the b squared minus 4ac, which turns out to be 0. So a discriminant of 0 means I have one real solution. 0 is a perfect square, so that is a rational solution. And then what I can do is I can plug that into my quadratic formula. 16 plus or minus the square root of 0. 0 just came from my discriminant. I do not need to recalculate that, all over 2. You can see here that I'm only going to get one answer, because if I take 16 plus 0 or 16 minus 0, I still just get 16. So that's why a discriminant of 0 just gives me one answer of 8. Why don't you try the next 2 rows, pause the video, and then play the video after you have tried them. So hopefully after you try these next 2, you got a discriminant of 16 for the first one, which meant I have 2 real solutions, which are rational, because 16 is a perfect square. When you plug that into the quadratic formula, you get a value of -2 and -6. The last example had a perfect discriminant of 45, which has 2 real solutions, which means it is irrational because that is not a perfect square. So when I get those answers, I would round to the nearest hundredth, and that would give me 4.85 and -1.85. So that is a review of the quadratic formula and using the discriminant to determine how many solutions and what type exist.